Hello everyone, in this video we are going to learn dynamic analysis. Okay, I will show how this dynamic analysis is done. Okay, before that I'm going to show you uh, what is dynamic analysis. Here you can see the dynamic linear analysis is a method used in structural engineering to analyze the response of structure to dynamic loads such as earthquake or wind. It involves modeling the structure as a series of linear elements, that is beam, column, and analyzing the behavior under dynamic loading condition. ETAB, that is extended three-dimensional analysis of building system, is software package for structural analysis and design development by computers and structure CSI company. ETABS is widely used by structural engineers for modeling and analyzing building and other structures. Okay, in previous video we have seen already for static linear analysis. Okay, then today we are going to learn response spectrum, that is dynamic analysis. Okay, what is response spectrum? The response spectrum method is a widely used technique in structural engineering for evaluating the dynamic response of structure subjected to earthquake, ground motion, or other types of dynamic loads. Here an overview of response spectrum method. Okay, first thing is conceptual basis, that is dynamic analysis. The response spectrum method is used on the principle of linear elastic dynamic analysis, assuming that the structure response remains within the elastic range. Okay, then ground motion input, it is depend on your acceleration time history recorded during the actual earthquake. Okay, it is recorded by Richter scale or seismogram. Okay, Richter scale is unit, and this seismograph is a device which is used to measure the earthquake. Okay, we are going to directly use software how to use dynamic analysis. This is the reports. Okay, our final reports for this is available in IS 1893. Okay, there you can see. Okay, come to software. See, as per our concrete frame building, I have used all that things similarly. Okay, from material defining to section defining, all things I have defined already. Okay, I am going to directly define load patterns. Okay, first I am going to define wind load in x direction. Okay, for IS 875 add for y direction also. Then I am going to define earthquake load. Define as seismic and 1893 2016. It's a newly amendment for y direction also, and add it. Then modify first. Okay, now I'm going to modify. Okay, how to modify I have mentioned already for concrete frame design. Okay, there you can check it how it is going on. Okay, for y direction also I'm going to modify. Modify earthquake load. So today I'm going to modify x direction only. I am going to on it, and only for y direction is going to close that and modify for y direction and click OK. Then click OK, define. Okay, then I'm going to define response spectrum, counter function, response spectrum. Okay, for IS 1893 2016, add new function. Okay, I'm going to name its response spectrum. Okay, for seismic zone 5, there is five zones which is defined by IS 1893. Okay, there you can check. I'm going to define for zone 5, that is severe. Okay, the damping ratio is defined in is 1893 0.05. Okay, as it is I have put and this is the graph. Okay, here you can see the linear x and linear y plot. I am going to define. Click OK, then again click OK, then define load cases. Okay, here you have to define as a response spectrum, add a new. Okay, RSX, RS response spectrum in x direction, the response spectrum, add acceleration u1. Okay, and RS here. Okay, scale factor is that as it is, to response spectrum, add for 3, and okay, here is model load case as it is. I am going to take it. Okay, for model combination method is CQC, and directional combination type is I am going to use, that is square root of sum of square root of square. Okay, so I'm going to take it as it is, and if you want to change model damping, change from here and click OK, then add new. For y direction, okay, for y direction response spectrum, add okay, and click OK. Okay, all things I have mentioned, click OK. Now come to load combination, define load combination, add default combination for concrete frame, convert to user, and OK, and click OK, then define. Here you can see mass source. If you want to add your mass source, add new mass source. Okay, specify load combination. I am going to add my dead load, cannot repeat dead load. Okay, then here you can click it, and okay, first I am going to live load it, then again wind load. Okay, mass source. Okay, then click OK. Yes. Okay, then click OK. Then again come to pdelete option. I'm going to define it is non. Okay, none. Do not use none. I'm going to use non iterative based on mass. Okay, mass we have defined. So okay, then see all things we have defined. Come to select and object type, and first assign all things. Assign frame load, distributed dead load, calculate the dead load. Okay, my column is 0.5 into 0.4 into 25. It's 5. Okay, add to existing, apply, then again select. Okay, deselect it and select beam. Select, my beam is 0.4 into 0.35 into 25. The 3.5. Okay, selected and apply. Then select both. Okay, before both selection, select floors, assign shell load, uniform. Okay, my shell is 0.15, 3.75, 75 to existing, and apply. Then again live load, select it. Live load I am going to give, that is 2. Apply. Sorry. Then select. I'm going to define earthquake load. Earthquake load is always half to the live load. Okay, apply. Then for y direction, apply, click OK. Then again combine, select beam column, assign frame load, distributed, click on live load. Live load is to select for earthquake load x direction 1, then apply, again select for y direction 1 and apply. Okay, then click OK, select again column beam, assign frame load open structure to wind parameter, yes, apply, then click OK, then click on floors, select, assign shell load wind pressure coefficient for x direction 1, apply, then select again for y direction or leeward, apply and OK. Okay, then close it, select all, assign all diaphragm, that is D1, apply and OK. Okay, all things we have assigned. Then I'm going for check model. Okay, okay, model has been checked and warning message were generated. Just come to base and click all the points for base only. So I'm going to make one story, select, assign, join, restrain, first restrain, apply and OK. Then come to upper side, analysis, set load. Okay, all the things I'm going to run. Okay, and analysis, analysis, I'm going to make response spectrum, save, analysis is in the process. Analysis is done. Okay, here you can see all the loads which we have applied and deflection is come. Okay, I'm going to check first reactions at the base, apply. Okay, here you can check the reactions at the base, movement also you can check. Okay, that movement will available. Okay, I'm going to check for response spectrum. Okay, for response spectrum you can see the values. Okay, okay, like this you can check. Okay, then I'm going to check for loads, movement for response spectrum. Okay, here you can check movement, shear, equivalent load for response spectrum X. I'm going to check for response spectrum Y. Okay, in this video we are going to check only response spectrum. Okay, that's why I'm going to show you only response spectrum. For other options you can check previous videos. Okay, then close. I'm going to check shell load for X, apply. Okay, this is the shell loads in response spectrum X direction, and for Y direction you can see this is the for Y direction. Okay, then shear also is you can check for maximum. Okay, this is shear for X. Okay, then forces also you can check. Here you can see stresses, apply. Okay, like this all things you can check. Then deflection, you can see the deflection in X, you can see. This animation is completed. So hope you guys understood how to create a response spectrum, that is dynamic linear analysis. Okay, like this you can see all story response plot also. Okay, here is story response plot. Okay, then you can see virtual work diagram for earthquake X. Apply. Okay, this is story response virtual work. Okay, then stress is deformation, all things you can check in reports also, in tables also, all things you have to check for your understanding. Okay, then design calculation, load frame, all things are available. Analysis result, that is structural output, base reaction, we are going to check. Okay, this is base reactions. Okay, hope you guys understood. Thank you.